Hey guys, this video is just going to be page 1 of your review. So we're going to start by looking at some graphing problems. So here it's asking us to write the equation of each line graphed at the right. All right, so again, whenever we're writing equations, when we're talking about systems of solutions, we're using y equals mx plus b. So we have to fill in the m, the slope, and the b, which is the y-intercept. So line A is this positive line here going up, this one here. So its beginning value, I always like to, whatever's easiest. I already see it begins at 8, so I can go ahead and fill that in. Now I have to find the slope, my rate of change. So I'm going to go ahead and go with the most obvious points that I see. I went up, oh, it's going by 2s, 2, 4. So I went up 4, and I'm going by 2s on the bottom. Be really careful. So I went from 0 to 8. Okay, remember, rise comes first, so it would be 4 over 8, which is also equal to 1/2. So y equals 1/2 x plus 8, because it's positive. So that's how I set that up. For B is my negative line. That's my line going down. I already see my starting point here at 16. So I already know it's plus 16. Now I just have to find my rate of change, or my slope. So here we go. I came down to 4 over 8. So that's going to be negative 1/2 over 16. Now the question is, what is the solution to the system of equations? Well, the solution when we're graphing, when it's visual and you can see it, is the point of intersection. So this is point number 8, 12. So 8, 12 is the answer that makes this true. Okay? All right, let's take a look at number 3. Use the space to prove it. Okay, here's the part where we go back and we plug them in. So we have y equals 1/2 x plus 8. I'm going to go ahead and plug in my numbers. So 12 equals 1/2 plus 8. Half of 8 is 4. 4 plus 8 is 12. Does 12 equal 12? Yes. I'm just going to check one for time saving purposes, but you can check the other one too. You really don't have to check when it's on a graph, because you can actually see it. All right, solve the systems by graphing. Y equals 6. That's one of our special types of equations. It's going to be crossing the y-axis. It's going to be a horizontal line crossing at positive 6. Sorry, my line is such a mess. It's not very good, but okay. So that's that one there. And then my second one is y equals 3x minus 3. So I'm going to go down to negative 3, because that's my y-intercept, negative 3. My slope is 3, which means I go up 3 over 1, up 3 over 1, up 3 over, oh, look what just happened. Okay, I can go ahead and connect my points. There we go. And the system to my solution is 3, 6. Okay. All right, number 5, same thing. I'm going to go ahead and find my first one is in slope-intercept form, so I'm going to go to positive 2. Make my dot. My slope is negative x. Remember, there's that 1 there, so I'm coming down 1 over 1. Down 1 over 1. Down 1, because it's just going by 1s, or I can go the other way. Okay, let's get my line on here. There we go. Okay, and now my second one equation is not in slope-intercept form. You will not have a bunch of these on the test, but just for practice, I want to get rid of my 3x. I want it on the other side. I'm left with 3y equals negative 3x, and that's a positive 6. Now I just have to divide everything by 3. So I get y equals negative 1x plus 2. Okay, sorry, I should have done that in another color. So I can graph this. I start at 2, and I'm going to go down 1 over. Oh, look what just happened. Look what just happened, guys. I didn't even catch it till I started to graph it. I ended up with the exact same equation. Okay, so guess what? I'm going to end up having two lines in the exact same location. They're going to be right. That doesn't match up, but they are the same line. This has infinitely many solutions. They're the same. Okay, so keep an eye out for stuff like that. Don't let it get, throw you. Okay, y equals negative x minus 3. I'm going to come down here. Negative x is negative 1x, down 1 over 1, or up 1, left 1. Okay. Oh, it was positive. So sorry, I made a quick mistake. Let me fix that. Thought it was negative, so we're going this direction. Up and over. Okay. Or okay, and now I have y equals 1.5x plus 5. Oh, or minus 5. Yuck. This one's going to be kind of weird to graph. That's okay. So I've got minus 5. And now I'm going to go up 1.5 over 1. So up 1.5 over 1. Okay, this one's really kind of strange. But you'll see what's going to happen. Up 1.5 over 1. Up 1.5 over 1. Up 1.5 over 1. This one, guys, was tricky. Going by 1.5s, again, you won't have anything quite this tricky on your test, but when I blew this up, you could see where I was going to the halfway mark, and then I went up 1.5. Okay, so this one, a little trickier, woo, than the rest, but I just did it until I found a good intersecting point, which happened to be at 4, 1. All right, here's our last one. That first equation is easy to graph. I'm going to go to plus 3. And then 1/2. So I'm going to go up 1 over 2. Or down. Go ahead and draw my line. And then my second equation, I got to scoot it around. I'm just going to add x to both sides. I have 2y equals x minus 6. I'm going to divide by 2. Don't panic, guys. Remember, there's a 1 there. So it just becomes y equals 1/2 x minus 3. Look what happened. Look what happened. I did it again. Same equation. Okay. So the easy part is now we already know that it's going to go just like that. Same equation. Infinitely many solutions.